Heat from the sun is strongest near the equator, causing warm air to rise and flow toward the poles. When the air cools, it sinks and flows back toward the equator. Because of the Earth's rotation, the air flowing back toward the equator turns to the west in both hemispheres. These are the trade winds, long well known to seafarers. They converge near the equator, an ideal place for thunderstorms to form. Most thunderstorms need rising air. Both converging air and warm air rise. Thunderstorms also need moisture. The sun's intense heat warms thousands of miles of ocean, providing a rich supply of water vapor as the surface evaporates. When this warm, moist air reaches higher altitudes, the water vapor cools and condenses, turning back into liquid water and forming a cloud. As the vapor condenses, it releases large amounts of heat into the surrounding air. More heat causes even more air to rise, beginning a cycle that can lead to threatening thunderstorms. A tropical disturbance is created when several large thunderstorms form and cluster together. Air rises at the center of the cluster, creating low pressure. Outside the cluster,
sinking air is compressed, creating high pressure. The high pressure air rushes in to replace the low pressure air, creating powerful winds. The Earth's rotation causes the winds of a tropical disturbance to swirl around its center, organizing it into the next stage on the way to what might become a hurricane, a tropical depression.
A hurricane has three main parts. The eye is the storm's low-pressure center. Around the eye wall has the storm's most violent winds, as well as torrential rains. Thunderstorms, spiraling outward from the center, become the rain bands that make up the rest of the storm structure. Traveling west